welcome to follow up. Let's have a look at problem 2672, number of adjacent elements with the same color. In this video, we're going to explain a solution based on traversal. So here the idea is that we just need to focus locally each time when we look at a query. So in this problem, we are given a zero-indexed array called nums of length m. So initially, all elements are uncolored. In other words, it has a value 0. So we are given a 2D integer array called queries, and each query is a list of 2 elements. So one is index and one is color. So for each query, we color the index position with color, the corresponding color in the array. So we want to return an array called answer of the same length as queries. So here, for each query, we need to have a corresponding answer elements, right? So here, answer I is the number of adjacent elements with the same color after the ith query. So after we fixed colored according to the first ith query, then we get answer I. So in such a sense, answer I is a cumulative effect of the previous I queries. So here, more formally, answer I is the number of indices on G, such that G is inbound, and the nums G equals nums G plus 1, and nums G does not equal to 0. So here, does not equal to 0 is an important assumption, right? So here are 2 examples. In the first example, the corresponding return is 01102, right? And for the second one, it's very special. You just have one position, and then after you change the color, so there's no adjacent colors, so we return 0. So here the constraints are the following. First, n is bounded below by 1 and bounded above by this large number, 10 to the power 5. And the queries is also in this range. And the index is in between 0 and n-1, and the color is in between 1 and 10 to the power 5. So with that said, basically we are ready to do the analysis or look at the coding part. So here, if you look at the hint, so the first hint actually is very suggestive, because at each query, so we're going to change or color one element. So we just need to focus on its 2 neighbors, at most 2 neighbors, right? Because the other parts are not affected, right? So this is the whole principle. In other words, we just need to look at things locally when we examine each query. So with that said, basically we can directly go to the coding, and in between we're going to explain the logic. So first I'm going to build an array. So this is 0 times m. So let's just simulate this procedure of coloring, right? So, and then we're going to initialize a result variable. So this result variable is going to hold the final answer, right? And then originally we have counting 0, right? Then we just need to linear scan. We do linear scan for the queries, and in between, so we're going to examine the neighbors and monitor or increment or decrement this counting variable count, and then we append it to the result. So this is our overall principle. So now let's iterate. So for I and Q, let's see, just for Q in queries, right? So for each query, because it's a length 2 list, let's first get the corresponding index and the corresponding color. That is, so we just unpack this part, and then we're going to check. So we need to this is the first one we want to pay attention to. If there's a change in either increment or decrement, we need to check if this one is not 0. So if it's 0, right, we don't need to do this part in the first if. So here we want to check the 2 neighbors. 1 is I plus 1, right? We want to make sure this is in bound, so that is less than n, or you can write less than or equal to n minus 1. And if array I equals array I plus 1, so because we intended to change the current color at index I, so if originally they are the same, right, then if we change to another color, then we're going to decrement this count by 1. So this is the one thing. And also we need to consider its left neighbor, that is I minus 1. We want to make sure this is also in bound, that is non-negative. And we consider if array I originally equals array I minus 1, right? If so, we're going to increment this by 1 again, right? So this is the first set of adjustment. So this is decrement, possible decrement. And then we're going to check, so let's first do the coloring. So we're going to set array I equals to the color. So in principle, this color can be same as this original color, but if it's the same, the below operation will compensate the result, make nothing happen. Like, so here is a possible increment. So after we note this one, we don't need to check if this is 0 or not, because the color by assumption will be greater than or equal to 1, right? So in this case, we are going to check if I plus 1 less than n, and the same thing above, basically array I. So if after change we have this position, then we're going to increment the count by 1. So similarly, if I minus 1 is greater than or equal to 0, and array I equals array I minus 1, then we're going to do the count by 1. So after each query, so we're going to append this effect, the current state of count, to the result. So afterwards, we just need to return the result state. So notice that after this possible decrement and possible increment, so after we append this count, we do not reset the count to be 0. The reason is here due to the requirement. So we return an array answer of the same length, and here answer I is the number of adjacent elements with the same color after I's query. In other words, the answer I is a combined effect of the first I queries. So with that said, basically we are ready to do a test. Yeah, it passes the first example. Now let's look at the generic case. Yeah, it passes all the generic cases. So that's basically about it for this problem. So here for this problem, I think the one of the key point is that we need to focus locally when we examine each query. So that's the one thing. So another thing is that we do the check for the index to be inbound and outbound. So one trick to do this, to avoid this trick, is that we can initialize an array of length n plus 2. In other words, we append one element behind, and we put another element in front. So this way, so we can use the index from 1 to n, right? So we just need avoid to do this index check. So it's actually good practice to try or modify. So with that said, that's about it for this video. Thank you.